Molybdenum-99 decays to technetium-99m, which we use for the production of radiopharmaceuticals in the clinic. It has a very useful decay of 65.9 hours, so the generators can last for up to 2 weeks. Best used within 1 week. This is the inside of the technetium-99m generator with molybdenum loaded on an alumina column, glass filters protecting the stationary phase to not leak out. You have an inlet needle with your sodium chloride that you add, the eluent, and then you have a vacuum vial that pulls through the eluent through the column, also through a 0.22 micrometer filter to sterilize. The whole setup is shielded by lead shielding to protect the operator from exposure. Technetium-99m ingrowth is a more technical topic, but basically the technetium-99m is formed by decay of the molybdenum. It is directly linked to the amount of molybdenum-99 still available to decay. So over time, the amount of technetium-99m produced will be lower. It is not dependent on the elution, so you cannot, if you elute more, it will still produce the same amount, but when you elute, you removed all the available technetium-99m from the generator, and it has to build up by molybdenum decay before you have enough. As you see here, if you don't wait till the proper elution time, you will get less yield than when you wait 12 or 24 hours for elution. So you can elute your molybdenum-99 generator more than once per day, but usually after 24 hours you get the most yield that it can offer at that point in time. When you do your elution, you have to do certain quality control. This includes instant thin layer tomography to make sure that it's only technetium-99m and not colloids, which is tiny little crystals or impurities that would get stuck at the origin, where you do a saline ITLC with your free precipitate or your technetium going to the solvent front, and your colloids or other impurities sticking at the bottom. You also do visual inspection in a safe way behind the lead shield. You measure your radioactivity yield. Your generator should provide you with a predictable amount of radioactivity. You test your pH, it should be more in the neutral to 6-5 range. Do aluminium breakthrough. If you go back, you would see that the generator column is made of alumina and you don't want the aluminium to go through, so it's a colorimetric test where you test a limit of alumina. Also, you measure your molybdenum breakthrough by first shielding your eluate. It will then stop the technetium-99m rays from going through, and then you can just measure your molybdenum rays, which can still go through 1/4 of an inch of lead, and then you subtract that amount from your overall amount and calculate the percentage of molybdenum breakthrough. You should not have more than 0.015 kilobecquerel per 1 megabecquerel of technetium. When you make your technetium kits, it is IAEA operational level 2A when you make it up or you compound it, so it should happen in a laminar airflow with properly trained personnel. This is the example of a generator that is being eluted. I'm just showing you quickly how it's done. So first you would put your eluent, which is your sodium chloride, 0.9%. Then you put a vacuum vial on, where you pull the eluent through the column by the vacuum. It should be a sterile vial and be vacuum properly to work. If you can't elute, then your vacuum will most often have a problem. So it's creating a pressure gradient that pulls the eluent through. Technetium is a very versatile radionuclide and can be incorporated in radiopharmaceuticals to monitor all areas of the human body: gastrointestinal cancer, liver, heart, brain, thyroid, you name it. I'm not going to go into depth here, but the cold kit chemistry has a correct amount of tin in to reduce, so the technetium comes out in a coordination state of 7. It's reduced with tin, giving electrons to something that is useful. It's incorporated into a radiopharmaceutical at the right oxidation state, and then the stability depends on the chemical environment and the type of ligand. Is the generator an ideal generator? It does supply a radio element in a chemical useful form. It has filters built in, so the eluate is sterile and pyrogen free. It is robust, and the separation of the daughter and mother nuclide is very predictable. You can store it at room temperature. It's properly shielded, sturdy and compact for shipping. And the eluate is physiologically acceptable, so you can use it for its own procedures like thyroid imaging or ventilation studies. Here is a reference that I used. Please comment down below if you have more questions.